All right, now, if we are talking of flowchart, and we already know that it's a symbol that we could use to represent our algorithm. And this flowchart now, for the sake of conventionality, each symbol has what it's being represented with. So now we talk of the first symbol we are talking of is oval shape. So this oval shape now, it's the oval shape we have now. It's either use it to start or to stop your program. So we call it terminal. So it's used for start or end your program. Then the next one is process. Process, the most commonly used symbols, it represents a specific task or step in a chart. So now whenever we talk of process, we use this rectangle to represent it. And this process now is normally anything that has to transform something. For example, now, if you write a program that will add a number A and B, first thing we need to include the number before we start adding it. So we need, at the edge of whenever this two things will add itself is a process. So you add first of all, you put A, go again, and put B. So this thing now cannot output anything until two of them is processed. So we now use process. Say A plus B. What we get the output answer. Then we can now calculate it. So it's as simple as that. Then the next major thing we need to take cognizance of is decisions. Decisions. In every program, there will be a time that we are meant to take decisions. And we do that using this diamond symbol. So decision, whenever you are meant to take a decision, you have two options. It's either you take yes or no, or either you say yes or no, or so in most cases we must indicate for this, we must indicate yes or no. We must indicate if you must indicate either you say yes or no. So that is it, or true or false. So meaning that if I choose this place to be yes, if I choose this place now to be yes, and I have no. So in my algorithm, assuming that I am testing a number that is greater than 9, right? So I will have an algorithm like this. I will start. Then the next thing I will do, I will put the number. Maybe the number is none. Input. Then the next part now is I have to test it. Is this number greater than? Is this number greater than 9? No. Is it greater than 9? If it's greater than 9 now, I say yes. Right? Probably it should display something. I can now use output. Output, it will display greater than 9. Then, if not, no. If say no, stop the program. Stop the program. So this one now, you can see that then I can still go like this. So the implication of this now is that whenever this program starts, it will receive a value. Maybe it will receive a value of 6. Is 6 greater than 9? No, it will say the program will stop automatically. But if it 6 is greater, if I choose something like 10 now, it will at this stage now it will check is 10 greater than 9? Yes, it will not pass through this place, and this one will now execute. So this is the implication of it. Then the next symbol we know is the flow line. The flow line is a good example of it. We normally go with that arrow to indicate the direction of your flow. Then we have output and input. So with this now, we understood the basics of this. Then there is yet another symbol that was not, that I didn't replace here now. Let me add the symbol. This symbol is a normal program. We call it, this a function in a normal program, meaning that, remember, it's possible to have a complex set of programs, right? So, and we keep on drawing it. So we can simply reduce our function. We can simply reduce the size of our algorithm by creating what we call subroutine. We create what we call subroutine now. Subroutines, meaning that you create a procedure, and that subroutine should have what? An identifier. So that's how it works. So let's see what I meant. For instance, I want a program, maybe I'm developing a calculator. So I think a calculator is the best symbol of that. So I want, whenever I input two numbers, input num 1 or num and num 2. If I put num 1 and num 2, see what happens now. Whenever I input num 1 and num 2, then I will choose and input maybe a symbol like this, which is x. Or I input, if I input x, is multiplication. If I input maybe if I input O, is division. So that means, instead of, I can simply create a simple subroutine so that I can reuse this thing. So I can now say our subroutine. So now if I want to make a subroutine of multiplication, right? So the ideal thing we are supposed to do is, remember that we are supposed to start with this. So I can allow it to give me what we call a parameter. So I can now put, and that parameter serves as an identifier. What I can use to identify this. So that's it. So I can call it tab. Yeah, parameter. Right. So the next thing we are going to do is, let's perform the calculation. Whenever you accept this, you should perform the calculation. So now we go. So now I've identified this now, and we can now add two numbers, maybe A multiplied by B. Then I can stop my program. So for the fact that this is the terminal, and I did not say start or stop at the terminal here now. So this name now serves as an identifier for this. So anytime I want to refer to this, I will just use this symbol. So I can simply create something of this method. The server scar. So I think this is a good basic. So we'll start answering the first question immediately. Okay, now the final thing I want us to